There is something funny about the way people imagine a trip to Mars, and I include myself in that mistake because the first picture that grabs your mind is always the same: a little ship crawling through black space. Everybody trapped inside like peas in a can. The sun far behind them, Earth shrinking away, and all the splendid terrors of the voyage pressing in at once. It sounds like the heroic part, doesn't it? It sounds like the place where the real courage is required. You leave home, you cross the void, you endure the radiation, the loneliness, the machinery, the fragility of the whole thing. And then at last you arrive. We are creatures of Earth, so we think in terms of departure and arrival. We take a train, we step off, the trip is over. We board a boat, we reach shore, the crossing is done. Even when I was younger, poking at mechanical things just to see why they behaved the way they did, there was always this childish assumption hidden in the background that getting somewhere was the hard part and being there was the reward. But nature is not sentimental in that way. And one of the first disappointments in physics is discovering that the universe never arranges itself according to the story you would have preferred. Mars is a beautiful example of that disappointment. You think the danger is the crossing because that is the dramatic image. But the image is cheating you. It is giving you the theatrical part and hiding the arithmetic. I've always liked those moments. By the way, when arithmetic humiliates drama, because it reminds you that reality has a tougher imagination than we do. You can tell yourself a grand story about brave astronauts conquering distance, and then a few quiet facts walk into the room and ruin the whole romance. Earth is moving. Mars is moving. The sun sits there holding everything in its grip, and neither planet is waiting for you to make up your mind. So the trip is not like throwing a dart at a fixed target, and it is not like sailing toward an island that politely remains where it is. It is more like trying to jump from one moving carnival horse to another while the whole carousel is turning and someone has forbidden you from using too much fuel. That is the part people don't feel in their bones at first. They imagine Mars as a place. Physics treats Mars as an event in motion. Those are not the same thing. A place sounds restful. An event sounds like trouble. If you reach Mars, you have not arrived at a quiet destination where you can stretch your legs, look around, and decide when you'd like to leave. You have intercepted a moving world at one particular moment in a celestial pattern that keeps changing while you are still catching your breath. That detail changes the emotional meaning of the whole mission. Suddenly, the landing is not the ending of hardship. It is the beginning of a much stranger bargain, because now you are standing on a planet that does not bring you home just because you're tired. I remember watching spinning things for absurdly long periods when I ought to have been doing something more respectable. Plates, wheels, little gadgets, anything that moved in a way that looked simple until you really paid attention. And the pleasure was always in noticing that what seemed obvious from a distance became wonderfully inconvenient up close. A mission to Mars has that same flavor from far away. The story is simple. Go there, do the job, come back. But the closer you look, the more the universe starts grinning at you. You discover that the outward journey, as brutal as it is, may not even be the true test. The true test may begin when the cheering stops, the dust settles around your boots, and you realize that planting your feet on Mars has not solved your problem at all. It has only changed the form of it and perhaps made it more intimate. Because now the question is no longer whether human beings can travel through space, but whether they can endure being trapped inside the clockwork of it. To understand why going to Mars turns into this strange commitment, you have to stop thinking about space as an empty stage and start seeing it as motion everywhere, because nothing out there sits still long enough for your convenience. And the moment you really accept that, the whole trip begins to look less like navigation and more like choreography. Earth is moving, Mars is moving, and they are not even moving at the same pace, which means the distance between them is not a number you can write down once and be done with. It is a living thing that stretches and shrinks depending on when you look. Earth runs on the inner track around the sun, completing a lap in about 365 days, while Mars lumbers along the outer track, taking 687 days to do the same circuit. And that difference sounds harmless until you picture it physically, because now you have one runner on the inside lane and another on the outside, and the inside runner keeps gaining ground, even if both are moving smoothly. I used to enjoy watching rotating systems for exactly this reason, because once you have two objects moving in circles, your intuition starts making quiet mistakes. You think the faster one will always catch the slower one easily, or that you can just point toward the target and head straight for it. But circular motion punishes that kind of thinking, and orbital mechanics is nothing but circular motion played on a gigantic scale. At certain moments, Earth and Mars line up on the same side of the Sun, and their separation shrinks dramatically, down to roughly 55 million kilometers, which sounds enormous until you compare it with the other extreme, when the Sun sits between them and the distance swells to more than 400 million kilometers, and this enormous swing happens not because the planets wander randomly, but because their different orbital periods constantly rearrange the geometry. If you imagine two hands on a clock moving at different speeds, sometimes they cluster together, sometimes they drift apart, and you don't control that pattern. You only observe it. That is already uncomfortable, because it means the trip is not scheduled by human desire, but by celestial timing. And the deeper discomfort comes when you realize that the closest approach is not automatically the best moment to launch. Intuition whispers that you should just fire the rocket when Mars is nearest. But intuition here is like trying to jump onto a moving train by aiming where it is now instead of where it will be. And if you have ever tried tossing something into a moving cart, you know that aiming directly at the cart is the fastest way to miss it. You have to throw ahead, letting motion do part of the work. And suddenly travel becomes prediction instead of pursuit. This is where the word dance stops being poetic and becomes literal, because you are not chasing Mars. You are agreeing to meet it somewhere in its orbit, and that meeting only happens if you launch when Earth is positioned so that your spacecraft can drift outward while Mars drifts forward. Both guided by the Sun's gravity, the spacecraft is not forcing its way across space. It is sliding along a carefully chosen curve, and the elegance of that always appeals to me because it replaces brute force with timing, like giving a gentle push to something at just the right moment instead of shoving it violently. But elegance has a price, and the price is patience, because that perfect alignment is rare. Earth has to be slightly behind Mars at launch so that during the months of travel, Mars moves into the rendezvous point exactly when the spacecraft arrives. And if you launch too early, you miss behind. Too late. You overshoot. And the opportunity closes like a door that only swings open every so often. When you start thinking in those terms, the trip to Mars stops being about distance and starts being about phase, timing, and inevitability. And I find that strangely humbling because it removes the heroic illusion that we simply decide to go whenever we want. The planets dictate the rhythm. The Sun conducts the motion, and the spacecraft is just a participant trying not to step on anyone's toes. You don't command this dance, you join it. And once you do, you are already moving with it, whether you like it or not. Once you accept that Earth and Mars are both in motion, the next instinct is to do something bold, something forceful, to simply point the rocket at Mars and accelerate as hard as possible, as if determination could compensate for geometry. And I have always liked that impulse because it sounds brave and slightly reckless. But physics has a way of punishing bravado when it is not accompanied by efficiency. Imagine you are already riding with Earth around the sun at roughly 30 kilometers per second, which is an absurd speed that you never feel because everything around you shares it. And now you want to leave that motion and intercept Mars, which is moving more slowly on a larger orbit. You are not just traveling across empty space, you are reshaping your path around the sun itself. And that costs energy, and energy in space means fuel. And fuel is the tyrant that quietly dictates what is possible and what is fantasy. If you tried to launch directly toward Mars when the planets are closest, you would need a violent acceleration to break free from Earth's orbital path and surge outward fast enough to catch a target that is already moving ahead of you. And when you finally arrive, you would face the opposite problem because you would be approaching Mars with too much speed and would need another enormous burn to slow down. Otherwise, you would fly past it and continue drifting into a solar orbit of your own. That kind of brute force strategy looks simple on paper, but explodes into impracticality the moment you calculate the fuel, and suddenly the heroic straight line turns out to be the most expensive path you could possibly choose. So engineers learn to be patient instead of aggressive, and this is where the idea of the transfer orbit enters. Not as a trick, but as a kind of quiet agreement with gravity. Instead of fighting the sun, you let the sun do most of the work. You launch from Earth, not directly toward Mars, but onto a stretched elliptical path around the sun, one that gently expands your orbit until it intersects Mars's path at exactly the right moment. The spacecraft coasts for months, not because we are lazy, but because coasting is efficient, and efficiency in space is everything. I have always enjoyed this notion that the spacecraft spends most of its journey doing almost nothing, just falling around the sun in a carefully arranged way, because it feels counterintuitive, like winning a race by gliding instead of sprinting. The elegance of the transfer is that you accelerate once to leave Earth's orbit, then later adjust to match Mars. And in between those burns, you simply let gravity carry you like tossing a stone so that it arcs naturally to meet a moving target. But this elegance creates another constraint, because that elliptical path only works if Earth and Mars are positioned correctly. When you depart, and that configuration does not occur often, Earth must be slightly behind Mars, so that during the months of travel, Mars advances into the meeting point while your spacecraft drifts outward. And the geometry of that alignment repeats roughly every 26 months. Miss that window, even by a small margin, and the transfer no longer intersects Mars at the right time, which means you either burn enormous extra fuel to compensate or abandon the attempt entirely and wait for the planets to arrange themselves again. This is the strange discipline of interplanetary travel, where the calendar is not set by human planning but by orbital mechanics, and you can prepare for years, assemble rockets, train crews, build Arbeitens, and still be told by the universe to wait because the timing is wrong. When the launch finally happens, the journey unfolds slowly, far more slowly than intuition suggests, because the spacecraft is not blasting straight across, but tracing that long arc around the sun. Chemical rockets, which remain the backbone of space exploration, simply cannot provide continuous thrust for the entire trip. So the spacecraft spends most of the time drifting, adjusting occasionally, and watching Mars gradually grow from a bright point into a recognizable world. The travel time ends up being about 6 to 9 months, depending on the precise geometry, and that duration is not an accident, but the natural consequence of choosing efficiency over brute force, you trade speed for feasibility, impatience for practicality, and the result is a journey that feels less like a dash and more like being carried along a predetermined curve that was decided the moment you left Earth, a reminder that once you commit to this path, you are no longer deciding how fast the story moves. The orbit already has. The moment the engines shut down and the spacecraft settles into its long arc around the sun, something subtle changes because the drama of launch is over, and what replaces it is not excitement but duration. And duration has a way of testing people more quietly and more deeply than any sudden danger. You are no longer accelerating, no longer busy with immediate tasks. You are simply drifting through deep space for months. And that drifting sounds peaceful until you remember that nothing about deep space is designed for human life. The spacecraft becomes your entire world, not metaphorically, but literally, a sealed volume of air, métal, wires, and screens, and everything you need to stay alive must either already be inside or be recycled endlessly, which gives the journey a strange closed-loop feeling, like living inside a machine that is also your habitat. I've always found that confinement becomes more unsettling when it stretches over time, because your mind starts noticing details you would normally ignore. The same walls, the same voices, the same routines repeating day after day. And outside the window, nothing but blackness and stars that do not seem to move fast enough to reassure you that you are going anywhere at all. Then there is the radiation, which is perhaps the most invisible threat because you cannot see it. You cannot feel it. And yet it is constantly passing through the spacecraft, through the hull, through your body. Energetic particles from the sun and from distant cosmic events, each one tiny but relentless. On Earth, we live under a magnetic shield and a thick atmosphere that absorb most of this bombardment, but in deep space, that protection disappears, and the crew is exposed continuously for months. It is not the kind of danger that explodes or announces itself. It is cumulative, statistical, a slow increase in long-term risk, and that makes it psychologically peculiar, because you are aware that nothing dramatic is happening while something very real is still affecting you. You might imagine the ship as safe, solid, reliable, yet every second particles are threading through it. And the protection is only partial, which gives the journey a quiet tension, like sitting in a light rain that you know will eventually soak through. Microgravity adds another layer to this strange environment, because the absence of weight sounds pleasant for about 5 minutes and then starts rewriting the body in ways that are less charming. Muscles no longer need to support your weight, so the body economizes. It begins to reduce what it thinks is unnecessary, and the legs weaken, the back softens, bones lose density as calcium leaches away, and the cardiovascular system adapts to a world where blood no longer pools in the lower body. Even fluids shift upward, subtly changing pressure in the head, sometimes affecting vision, and all of this happens gradually, day by day, without a dramatic moment you can point to, which makes it more unsettling because the transformation is quiet. Astronauts exercise intensely to counteract these effects, but exercise itself becomes another routine in a long sequence of routines, each designed not to improve performance but to prevent deterioration. And beyond the physical effects, there is the mental landscape of deep space, which is harder to quantify but no less real. Communication with Earth continues, but the distance grows. The delay increases, and the sense of separation becomes more than symbolic. Home is not just far away. It is unreachable in any meaningful sense, and the knowledge that any emergency would unfold without immediate help sits in the background of every decision. The crew becomes self-contained not only physically but psychologically, relying on each other in ways that no ordinary mission requires. And that dependence can be both stabilizing and heavy, because the same small group must handle every problem, every disagreement, every unexpected event. After months of this slow passage, Mars gradually brightens ahead, and the destination that once seemed abstract begins to look tangible. But by then the journey has already reshaped the crew, not through sudden heroics, but through endurance, through repetition, through the steady accumulation of small stresses that never quite vanish. The crossing does not end with a dramatic confrontation. It ends with a realization that the human body and mind have been quietly negotiating with an environment that never intended to host them. And the negotiation has only just begun. Arrival on Mars feels, at first, like the resolution of everything that came before, because the months of drifting finally compress into a violent, delicate descent through a thin atmosphere. Parachutes deploying in slow motion, engines firing close to the surface, dust exploding outward as the lander settles. And then silence, the kind of silence that tells you the machinery worked and you are still alive. I can imagine the first step onto the surface carrying that peculiar mixture of triumph and disbelief, boots pressing into red dust that has not been disturbed by human movement before, instruments unfolding, antennas turning toward Earth. And for a short time, the mission looks exactly like the story we expected. Exploration, sampling, walking carefully in reduced gravity, watching the horizon curve under a pale sky. The human mind loves this phase because it feels productive, tangible, and controllable. And it gives the comforting impression that the hardest part has already been survived. After all, the spacecraft reached Mars. The landing succeeded. The crew is functioning, and the planet, though hostile, is at least solid beneath their feet. But there is an uncomfortable question that always creeps in once the first wave of activity settles, and it is a very ordinary question, almost embarrassingly simple. When do we go home? On Earth? That question is trivial, because departure is usually a matter of scheduling, fuel, and weather, and we carry that intuition with us without noticing. Yet Mars does not behave like a remote outpost waiting for pickup. And the moment you try to answer that question honestly, the geometry of the solar system returns with a kind of quiet authority. While the crew was traveling, Earth did not remain in a convenient position. It continued racing along its inner orbit, moving ahead at a faster pace. And from the surface of Mars, if you plotted the positions carefully, you would see Earth gradually sliding away. Not dramatically, not suddenly, but steadily enough that an immediate return becomes far more complicated than it sounds. The spacecraft that brought the astronauts there was timed to intercept Mars under a specific alignment, and that alignment no longer exists. Once the landing is complete, I've always found this moment fascinating because it reveals how deeply our thinking depends on stationary assumptions. We imagine the journey is reversible, like walking across a room and then turning around. But orbital mechanics does not grant symmetry so easily. To leave Mars immediately and head back toward Earth would require accelerating into a trajectory that catches a planet already pulling away, which means adding enormous energy to compensate for the unfavorable geometry. The rocket on Mars would need to climb out of the planet's gravity well, then reshape its orbit around the sun aggressively enough to intersect Earth's new position, and that maneuver quickly becomes impractical with current propulsion technology. It is not that returning is impossible in principle, but the fuel required would be so large, that the mission architecture collapses under its own weight, you would need to deliver massive propulsion capability to Mars in advance. Something that multiplies cost, complexity, and risk far beyond what is considered feasible. There are theoretical approaches that try to shorten the stay using higher energy trajectories, both outbound and inbound, essentially forcing the geometry to obey human impatience. But those approaches carry their own penalties. More energy means more fuel, more mass, larger launch vehicles, and harsher re-entry conditions, and sometimes the supposed advantage of a short stay disappears when the return trip becomes longer or more hazardous. The irony is that the simplest plan, the one that uses the least fuel, is also the one that removes flexibility, because it locks the crew into waiting for the planets to align again. That waiting is not an accident or a delay caused by engineering. It is embedded in the logic of the transfer itself. The astronauts did not just travel to Mars, they synchronized with it. And once synchronized, they must remain part of that moving pattern until a new opportunity naturally emerges. So the paradox of arrival appears quietly, almost politely, not as a failure, but as a consequence. The crew stands on Mars, capable, prepared, surrounded by equipment designed for exploration. Yet the simple act of turning around and leaving is no longer available to them. The planet beneath their feet is not just a destination, but a temporary anchor in a larger motion. They cannot hurry, and the realization settles in gradually, like noticing that the train you boarded is not stopping anytime soon, no matter how ready you feel to step off. Once you realize that leaving immediately is not an option, the mission quietly transforms from an expedition into a residency, and that shift is more profound than it first appears. Because now the crew is not just visiting Mars. They are living inside a clock that will not speed up for them. The alignment needed for an efficient return does not reappear in weeks or even months. It unfolds only after the planets continue their motion and rebuild the geometry. That allows a low energy transfer back to Earth. And that takes roughly 500 days. 500 days is a peculiar number because it is long enough to stop feeling temporary and short enough that you cannot redesign your life around it. And the astronauts find themselves in that strange middle ground, committed but not settled, waiting inside a world that was never meant to host them. The idea of a long-stay mission sounds technical, but in practice it means building a fragile pocket of Earth on a planet that does not forgive mistakes, and then maintaining it continuously while time passes according to orbital mechanics rather than human preference. Mars offers solidity beneath your boots, but that solidity is deceptive, because everything required for survival must still be manufactured, recycled, or shielded. The atmosphere is mostly carbon dioxide, about 95%, useless for breathing and thin enough that pressure drops to less than 1% of Earth's, which means the environment is not merely hostile, but actively incompatible with human physiology. Without a pressurized habitat, bodily fluids would begin to boil even in the cold. And the suit you wear outside is not protective clothing in the ordinary sense. It is a portable life support system that must function perfectly every time. That perfection becomes a daily discipline because any failure is not an inconvenience, it is an immediate crisis. On Earth, redundancy is reassuring. On Mars, redundancy is survival. Every seal, every valve, every connector carries the quiet weight of consequence. And the crew learns to treat routine maintenance with the seriousness of a surgical procedure. Radiation, which followed them through deep space, does not disappear after landing. And in some ways it becomes more complicated. Mars lacks a global magnetic field. and its thin atmosphere provides only limited shielding, so cosmic particles continue to strike the surface. The habitat must therefore be designed with protection in mind, perhaps partially buried under Martian soil, to use the regolith itself as a barrier, and this detail always strikes me as a kind of improvisation. Humans arriving on a barren world and immediately digging into it for safety, not to hide, but to borrow protection from the planet's own dust. The solution is elegant and slightly humbling, because it reminds you that even advanced technology sometimes falls back on simple geometry. More mass between you and radiation reduces exposure, yet building and maintaining that protection becomes another ongoing task. Not a one-time effort, but a continuous negotiation with environment and time. Then there are the dust storms, which are not local gusts, but planetary events that can expand until they cover Mars entirely, dimming sunlight for weeks and coating surfaces with fine abrasive particles. Solapens, if used as a primary energy source, risk losing efficiency precisely when reliability is most needed. And this is why many mission concepts lean toward compact nuclear reactors. Not because they are dramatic, but because they offer steadiness, a constant supply of power independent of sunlight. Power on Mars is not a convenience. It is the difference between a functioning habitat and a silent one. And the crew becomes acutely aware that energy is the thread connecting air circulation, temperature control, water recycling, and communication. The entire base hums quietly, and that hum becomes synonymous with safety over 500 days. Routine becomes structure. Structure becomes endurance. And endurance becomes the real measure of the mission. Exploration continues. Experiments proceed. Samples accumulate. But beneath those activities lies the persistent knowledge that departure depends not on readiness, but on alignment. The crew is not counting down to a launch they can trigger at will. They are waiting for a window that arrives when the solar system decides living on Mars during that interval is less about dramatic heroics and more about sustaining a fragile equilibrium, a prolonged exercise in patience, where survival is measured in ordinary days, stacked carefully together, each one passing under a pale sky, while the geometry of the planet slowly, invisibly, moves toward permission. After roughly 500 days, something almost invisible begins to change. Not in the habitat, not in the sky, but in the geometry of the solar system itself, and the crew may not feel it at first. Yet everything they have endured has been quietly moving toward this moment. Earth has continued along its faster orbit. Mars has followed its slower path, and the alignment that once trapped them now begins to rebuild in reverse, like gears slowly turning back into place. There is something deeply non-human about that kind of waiting, because nothing dramatic announces it. No alarm sounds. No, sunrise looks different. And yet suddenly the mathematics says the door is opening. The return window appears not because the astronauts are ready, but because the universe finally permits it. And that distinction always fascinates me, because it flips our usual idea of exploration. We like to think we decide when to leave, but here departure is granted, not chosen. And after more than a year of living on Mars, the idea of going home must feel both relieving and strangely unreal. The ascent from Mars is its own fragile performance, a smaller vehicle lifting off from a planet that has never offered second chances, rising through thin air, climbing toward orbit where the return spacecraft waits. I imagine that moment carrying a peculiar tension, because everything that kept them alive now stays behind. The habitat, the routines, The dusty horizon, all of it shrinking as Mars recedes below. Docking in orbit becomes more than a technical maneuver. It is the handshake that reconnects them with the long path back to Earth. And once again, the engines fire, not for a dramatic sprint, but for another carefully shaped arc around the sun, retracing the same logic that brought them here. The return journey mirrors the outbound trip, another 6 to 9 months of confinement, radiation, and microgravity, except now the crew begins already fatigued, their bodies adapted to partial gravity, their muscles weakened, their bones slightly diminished, carrying the accumulated wear of nearly 2 years away from Earth. The spacecraft drifts again. The sun becomes the silent guide again, and Mars fades behind them, while Earth slowly grows ahead. A reversal that is emotionally simple but physically identical to the first crossing. When you assemble the timeline carefully, the scale of the mission becomes difficult to ignore. 7 to 9 months traveling outward, then about 18 months on the Martian surface, then another 7 to 9 months returning, added together, and the mission stretches to roughly 34 to 36 months. Almost 3 years. 3 years inside a sequence that you cannot interrupt once it begins. That duration changes the character of the entire endeavor. This is no longer a daring visit or a quick scientific expedition. It becomes a voluntary exile measured in hundreds of days, where every stage depends on celestial timing and every delay is measured in months. The astronauts leave Earth knowing they will not see it again for nearly 1,000 days. And that knowledge reshapes the meaning of risk, equipment failure, medical emergencies, psychological strain. All of it unfolds inside a time frame that offers no rapid return, no immediate rescue, no improvisation beyond what the crew can manage themselves. And that is where the idea of reaching Mars quietly transforms into something broader. The technological challenge of building rockets is enormous. But rockets alone do not define this mission. What truly defines it is endurance, the willingness to live inside a schedule written by orbital mechanics to accept distance, not just in space, but in time. The frontier is no longer the gap between planets. It is the stretch of months and years that separates departure from return. Traveling to Mars, in that sense, becomes less about speed and more about patience, less about propulsion and more about resilience. A test of whether human beings can adapt not only to hostile environments, but to prolonged commitment under conditions that cannot be hurried. By the time Earth grows large in the window again, the journey has already answered a deeper question, not whether we can reach another world, but whether we can endure the long silence between leaving and coming back, because the distance that matters most is not measured in kilometers. It is measured in the time you agree to spend away from everything familiar